Welcome back to this YouTube tutorial series on creating a recursive descent parser for a calculator language. In today's video, we're going to be implementing some extendability of our calculator and then also fixing up an error that occurred that I forgot to check up on. So if I was to give the following example of 2 raised to the third by PEMDAS, the order of precedence, 3 to the third should operate first before 2 being raised to the value of this computation. So it should be 3 to the third, which is 9, and then it should be 2 to the ninth. But actually, if we were to type this out, 2 to the ninth is not 512. This is because our calculator is operating from left to right. It's actually doing 2 to the third, taking that, which is 8, and then taking 8 to the third, where 8 to the third, as we see here, is 512, whereas 2 to the ninth is also 512. Interesting. So let's actually do 2 to the third to the second power. So this is right here is 2 to the ninth. It should be 2 to the ninth, but instead it is actually 8 to the second power, as we see. So it's operating left to right, but we want it to operate from right to left. So what this should be is actually 2 to the ninth, which is 512. So in order to do this, we're going to go back up to our T3, which is where we have our operator 3, where operator 3 is where we perform our exponentiation. So here, what we actually want to do is flip this around. We do not want to return the T3. We actually want to store T3 in value, and then we want to return the operation 3 of these values. And hold on real quick. Everything's lagging a little bit. And we're going to pass in next here. And we're going to pass in value. So essentially what we're doing here is we're calling T3. So our temp is going to call T3. Our T3 is going to be passed in. We're going to pass in the next from our factor. Okay? And then what we need to do is, before performing an operation on the value returned from factor and the value returned from this factor, we need to actually get the value from this T3. So then what we're going to do is we're going to call T3 again first, then pass in this next value. So we get this factor value here, we pass it in as next to this T3, and remember T3 is only level 3 precedence. So no multiplication, no subtraction, no nothing except for exponentiation in this case. So we perform this, and then we return it, and then we return the operand 3. So this is actually where we perform our operation. We perform it after our T3, and then we return that. So now after we fix this, we can now run this again. I'm going to go 2 to the third to the second power. So 2 to the third to the second power is now 512. Now our operation is going from right to left instead. So now we are to begin extending our code. The purpose of this is simply because in future tutorials I'm going to be reusing this calculator in some of the examples. So to begin with, I made 3 Python files: an iterator Python script, a parser, and then a scanner. We're simply going to take our code here and partition it into these 3 files. So to begin with, the iterator. I'm going to take this iterator class and paste it in its own script. And this is because the scanner and the parser both use the iterator itself, which is why we want to put it into a separate file. That way we can call it from both. And also use this in other code as well. In the scanner, I'm going to take our token and our isNumeric function and put that in here as well. And then I'm going to take our scanner paste that in here as well. And one thing we're going to actually do here is we're going to import our iterator. So we're going to say from iterator, import iterator. If we go down here to the very bottom, one thing we did was that we actually appended the $sign token to indicate the end of the input. We're actually going to take this and we're going to put this in our scanner function, because we don't want to have to repeatedly do this after each instance of calling our scanner. So we're going to do this instead inside of our function. So before we return, we're simply just going to append this. So anytime we have a return statement, a return tokens instead of return none, we're going to append these $signs. That appears to be it. And so now we're going to take our parser and we are going to make a class out of this. And so what we're going to do is we're going to say class parser. And before we do that, I'm going to say from iterator, import everything. From scanner, we want to import the scanner itself and the tokens. And so what we're going to do here is take all these functions and we're simply going to paste them inside of our parser. And we're going to make them all private. Code is unreachable, return none. Okay, here we go. And so what we're going to do is we're going to say final self, and we add the 2 underscores to indicate a private function. And so here we're going to say underscore final, underscore factor, add the self to each function, so now I'm simply going to go through this and come back when I finish. And so now I've run through all the functions, and because we made these private variables, we actually need to change every single time we call one of these functions again to self.term. So now I'm just going to go through all these functions and change it to the appropriate function calling. And now I've completely done that. I've gone through all the functions and appropriately adjusted the names. And one thing I'm going to do is I'm actually going to fix this final function. That way we get rid of these errors. And we need to actually have a private variable. We're going to call it, or it does not necessarily have to be private, but we need a variable called variables. It's actually going to hold our variables. So we're going to say self.variables, self.variables here, and just go through all these. All right. And as you've noticed, we actually made our start function private. This is because we don't want people to call the start. What they want, what we want them to do is call an intermediary function. We're going to call this parse. So we're going to return self.start of the tokens. Unresolved attribute. And for future examples and future tutorials, we're going to be implementing lots of variables. So we're going to make 3 functions we're going to make add variable, remove variable, and replace variable. So here we're going to say add variable, the name of the variable, and its value. I'm going to say variable is equal to a dictionary entry, and we're going to say self.variables.update of the new variable. And this is going to assume that the new variable name is not present. So if we already have x in here and we try to add variable x again, this is not going to be a good sign. If we were doing that, we would want to use the replace method. So we're going to say remove variable, just the name. I'm going to say if name in self.variables variable is present in dictionary, then we're going to simply delete that dictionary entry. And the last function is going to be replace variables. So we're going to have a name and a value. First, what we're going to do is we're going to say remove variable, and then we're just going to add the variable. So now we're finished making our calculator extendable. Let us actually go back here and try an example. So we're going to say from parser, import parser. We're going to say x is equal to scanner of, let's say, x to the third plus 5 from scanner import scanner. And then what we're going to do is we're going to say my parse is equal to parser. What we're going to say is we're going to say print my parse.parse of x. But before we do that, we're going to add a variable. So we're going to say my parse.add variable. Name is going to be x, and value, let's say, is going to be 3. So let's get rid of that. Let's run this calculator, and we get 32. So 3 raised to the third power is 27, and then 27 plus 5 is 32. So there we have it. It's working. And in the next video, we're actually going to be updating our calculator one last time. So stay tuned.